bahasa we call it as hubungan air larian lebat hujan, or in English is rainfall and runoff relationship. Okay, since we have international students, I'll be explaining in English, and those who have difficulty in understanding, you can feel free to message us or email us or whichever that is easiest. Okay? So before I go in depth about the whole setup that we'll be doing in lab, I would like to ask you guys, do you know what is runoff? Alright, so in this setup here, what we're going to do is actually we're going to do simulation. There'll be there'll be sprinklers here that will be sprinkling water, simulating rainfall. And here, the base is actually land. It's an imaginary land. So in this particular set here, we are using sand. But what I want you guys to imagine now together with me is, imagine in a real life scenario, okay? First, I want you guys to imagine yourself in a forest. Okay, imagine a forest, a lot of trees. Okay, you can imagine the forest floor that is covered with leaf litters and soil. Okay, now imagine there is rainfall. How do you imagine? How is the rainfall going to come over, intercepted by the trees, and then landing up on the floor? And it will be washed out with all the processes, hydrological processes that you guys might remember in filtration. All these things comes along, and then it will be going to the river. In this case, it will be discharged in this particular part here. Okay, so now in the same scenario, I want you guys to move from a forested area. Now I want you guys to imagine that you guys are in a plantation. Okay, the common area in tropics is oil palm plantation. So imagine you guys are in oil palm plantation. Oil palm trees, and the same rainfall is coming in. Alright? So imagine the processes between it, the interception, and how it hits the soil and it's going to flow out as runoff. Okay? So can you imagine the water, the sedimentation, the erosion process that is happening, and it's going to end up to the river stream. As you can see from here, the water is clear, but clearly in the real environment that is not the case. You can see in our rivers, when you're driving through in any roads or highway, you can see what is the color of the river. So that is a similar thing, the concept that you guys will be seeing in a real situation, and this is a simulated situation. But the concept and idea is the same. Here, there is no undulation. It is flat area. In real situation, we'll be dealing with terrains, we'll be dealing with plants, we'll be dealing with different types of soil, which a mixture of sand, silt, clay, gravel, and all this so on. So the process is more complex. And when we are having rainfall itself, there is multiple scenarios of rainfall. Heavy rainfall, mild rainfall, and multiple rainfalls. What is meant by multiple rainfalls is that there is a rain event, let's say 15-20 minutes or 1 hour, whatever the rainfall is, and then it stopped for a while, and then it starts raining again. So the behavior pattern for the runoff, it will be different. This is because it is influenced by the level of the soil saturated with water. So all these are the processes that I want you guys to keep in mind while we are going to go through this experiment on rainfall and runoff relationship.
Assalamualaikum warahmatullahi wabarakatuh, and very good morning to everybody. Okay, my name is Zainab. So I would like to explain how to use this apparatus. Okay? Okay, my colleague, Dr. Vani, has been explained on the introduction, the real life of this application. But now my turn is to explain to you how to conduct this experiment. Okay, in this experiment, okay, you will have three tables here. The first one on table 1. Table 1 is the calibration depth discharge. So you will get the data and plot the data to get the calibration curve. And the second one, you will run for the first experiment what we call it as a determination of the storm hydrograph for the upstream. Okay, and then the second experiment, okay, you will do on the determination of the storm hydrograph at the downstream, and the final one we will do it for the multiple storm for the entire catchment area. First one, on the table 1, you need to have the data of the relationship between the depth and the discharge. Okay, this is the valve. What you need to do is you switch, you turn on the valve, and you will see the rising of the water level, determining the discharge of the flow going into this part. Okay, and it will outflow into this container. So from this container, you need to measure the water level or water depth here. Okay, you will see the rising of the water level here. Okay, and then the second reading, you need to increase the water level. Okay, repeat the procedure and measure the depth of the water. You will be repeating the same procedures until for the 7 data.
Alright, now let's try to run the experiment. So we are setting up the device, switching on the pumps and warming it up.
Okay, now we will do the first experiment for the storm at upstream for the entire catchment area. Okay, this is on the valve at the upstream. Okay, we got 8 valves here, the sprinklers. So we need to open only 4 valves, representing for the upstream. Okay, and if you see inside, you can see the infiltration or runoff happen inside the catchment area. It will go to the downstream, and later it will infiltrate into the soil and goes to the container, whereby you need to record or measure the water level at this container. Okay, we will do the measurement of the water level based on 10 seconds of the rainfall. Based on 10 seconds of the rainfall. So, take a reading for the first experiment. Okay, we can on the rainfall first. Okay, there is a rainfall of the sprinkler for the upstream. Okay, we start the stopwatch for 10 seconds. We will take the reading for every 10 seconds. This is the reading of the water level. Read. Go slow. Okay. Read. 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 Okay, we will do this procedure until for 2 minutes. 2 minutes and 120 seconds. Okay? Okay, once we reach the 120 seconds, we need to stop the pump. But the stop will still continue. Okay? So when we stop the valve, okay, you will see the reduction of the water level. Okay? You will see the reduction of the water level. So you need to calculate the reduction of the water level based on the 10 seconds. Similarly, what similarly like what we have done previously until the last 3 readings is a constant. Okay, then you can stop the experiment. Okay, that's all for the experiment 1 at the upstream.
Explained by Dr. Zainab earlier, we've done the experiment for the catchment upstream. Okay, now what we have to do is we are going to repeat the entire process, but now we are going to simulate the rainfall for the whole catchment. So this is how the whole catchment rainfall will look like. If you can see, there are valves here. 1, 2, 3, 4 sprinklers sprinkling in water. Earlier, the experiment we only did for upstream, where these sprinklers were off and only this. So we are going to let the rain fall for 2 minutes, then stop, then take the measurement and repeat the same process. And for the next measurement, multiple rainfall, what we'll be doing is the same experiment, let it rain for 2 minutes, and then we stop because we do the measurement for 2 minutes, and then we switch on again the pump for 2 minutes, and then switch it off again and re-monitor. So that is how we are going to do the experiment for multiple rainfall within a catchment. So that's about it on the theoretical part of this particular experiment. Hi again. So earlier we did on the laboratory part. I would like to ask you guys certain principles if you guys knew, and these are the things that you guys need to understand before you can really interpret what we did earlier. So the first thing that I mentioned is on runoff. I hope everybody knows what is the meaning of runoff. It's quite simple. There's 2 things. One is run on, one is run off. What is run off is you have surface. You have soil surface, and this is your trees, and let's imagine this is a cloud. So when there is rainfall, okay, there is interception, and finally the rain drops, and it will be flowing on towards the river system. So this particular flow here is what is known as runoff. So the process here is actually influenced by a lot of processes which comes into the soil type, rainfall intensity, plant coverage, and ground coverage, and all these things. And one idea or concept that you need to understand is that when you are dealing with rivers, it is not empty. There is some initial rate of flow, and this is known as base flow. And when we're dealing with rainfall, the increase in this water level, the decrease, and how it returns to normal, the flux and everything is what we did in our experiment earlier. So let's look on the theoretical part on how to draw the calibration curve and the discharge curves.
Assalamualaikum warahmatullahi wabarakatuh. Now I will explain to you how you can do your report according to the experiment that you have done previously. So H2 experiment, rainfall runoff relationship. Basically, you have done for the 3 experiment. Okay, the first one, okay, you examine the storm at the upstream, upstream. And the second one, storm for the entire catchment area, and the for the multiple. Okay, so we have 3 tables there, so you need to fill in all the tables. For the first one, okay, we have table like this. Okay, we got the time, so because we have taken the data for every 10 seconds. Okay, 10 seconds. So this is the depth. Okay, depth in millimeter, and this is the discharge. Okay, so for the column of the discharge, you can't get the data right, but you can have the data by plotting the calibration curve. Okay, calibration curve you need to plot using the table H21. Okay, calibration curve. So we got the data here. So this is discharge. Okay, liter per minute. And we have the depth. Yeah, the depth in millimeter. So from the data in table 1, so you need to plot the graph. So you will get like this, the graph, right? So this is the scale. Okay, for example, 10, 20, 30, 40, 50, 60, 70. And this is the discharge. 10, 20, 30, 40, 50, 60, and 70. So how we can get the discharge here? So this one you might have maybe 4, 6. This is from the experimental data. Okay, to get the discharge at 10 seconds, so you need to know the depth is 4. So 4, if you interpolate, you will get somewhere at here, right? So this is 4 millimeter. So you just extend the line and then project to the y-axis. This is the value of the discharge for the depth of 4 meter. It might be 3 meter per second. So the answer here is 3. Okay, similarly for the 6 of the water depth, somewhere here, okay, you just extend the line and project to the y-axis. So this is around 5. And then this is 5. Okay, you repeat the same process until you fulfill all the data here. Then you need to plot the hydrograph. Okay, the hydrograph means for the discharge against the time. Okay, so you plot discharge against the time. So you might have something like that. Okay, so you need to plot the graph. Okay, make sure you plot the best fitted curve. Best fitted curve, because some student, if you got data like this, okay, please don't do like that. Don't make sure that you will fit all the value here, because this, what we call it, is a outliers data. Just choose the best fitted curve of your hydrograph. So from this hydrograph, okay, for example, we will get what is the peak flow and what is time to reach the peak. Okay. This one for the upstream. For example, similarly, you need to plot the hydrograph for the entire catchment area and also for the multiple. Okay, you might have the graph for the multiple similarly like this, yeah. Okay, time in minute. So because we have 2 minutes with rainfall and then 2 minutes without the rainfall. Again, 2 minutes with the rainfall and another 2 minutes without the rainfall. So your hydrograph should be like this. Okay, this is what we mean by the constant reading at the end of the experiment. Okay, this your graph for the multiple storm may looks like this, right? Okay, so here, so I want you to investigate whether your first peak similar or not. Okay, similar or not, and the time to peak, what is the difference between the first peak and the second peak. Okay, you need to analyze in terms of the peak flow and time to peak. Okay, this is what my colleague mentioned about the base flow, right? This is the base flow. Okay, so the intensity of the flow of the intensity of the flow is you run for the 2 minutes, right? So you need to find what is the intensity of the rainfall. Okay. I think that's all for us. So wish you all best of luck. Okay, Dr. Bani, do you have anything you want to tell students?
Yeah, the one keynote that I would like to emphasize is when you guys are doing this experiment, keep the real life situation in your mind. And this is applicable for modeling approaches. And in real life situation, you'll be using with runoff plots, runoff sheets or other field related measurements. But the principles are similar as what Zainab explained earlier. So all the very best.
Yeah, thank you.
Thank you.